Okay, in this video clip, I will show you how can we write the program using the recursion side. We start with the public class and recursion demo. Public static void main string argument s, and I just print the result to the screen. Okay, so it is a factorial of 5, for example. Okay, public static int and factorial of int x. Okay, now you have to start with the base case, because if you fail to catch the call of the method in this base case, your program will infinitely call itself. So you have to catch when the input is in the base case. So in my case, I will use if x is 0. This is the base case, right? So should return 1. If not, return x times factorial of x minus 1. That's all. And check the result. Can you see? This one is a factorial of 5. This is correct. Okay, so this is the first idea. Next, I'll show you how can we write the program in the next problems. Okay, so a moment. I'll start Chrome again. Okay, guys, I will show you the next example. This is actually like a standard application, standard function. Okay, guys, maybe you know this one. This is called the Fibonacci function. Okay, then it's quite simple. You start with 1 and 1, and the next term is the last term plus the term before the last one. So this one will be this plus this. So it must be 2, right? And then same. 3 and 5 and 8, 13, 21, 34, 55, and 89, and this is we call the Fibonacci series. Okay, and if you divide this term by the previous one, the result will finally converge to a constant called the phi number. Can you see? This one is the constant finally. Okay, so this is a constant we call the phi, or many people call this constant like golden ratio or any other thing that we call this is the most beautiful ratio in the world. So this one is the Fibonacci series. It's quite interesting, right? Okay, guys, I will show you how can we write the Fibonacci series. The idea is still very simple again. Okay, so can you see? We can have the base case like this. Oh, I'm sorry. I have a lot of. Oh, Okay. This term is the can be calculated from this term and this term, right? And of course, this term calculated from this and this, and this can be calculated from this and this, but this term and this term is the constant. So if you start with the first term, second term, third, fourth, guys, look at this. If we input like the index or Fibonacci number as the Fibonacci series at the index 7, what is the value? How can you find it? Of course, the base case must be Fibonacci of 1 and 2 must be 1, right? This is the base case. So it's quite simple, right? So I will write another function here, public static int Fibonacci, Fibo, and int and index. Okay, it will be very simple, right? You have to start with the base case. So if the index is less than or equal to 2, you have to return this one, right? I'm sorry, guys, my Chrome here. If index is less than 1 and 2, you must return 1, okay? So I will return 1 in my case. If not, how can you do it? You have to return something like this. Return Fibonacci of index minus 1 plus Fibonacci of index minus 2. And let's try. System.out.print line Fibonacci of index 3. So Fibonacci of index 3 should be, what is it? Should be 2, right? Okay. So I have to run it. Yes, it is 2, right? So I will write the program that start from for in I is 1 and I less than 50, I plus plus, and I will print index I. Okay, run. You can see that there's something very slow here, right? That actually should not be slow because the number is not too high, right? 1, 1, 2, 3, 5, 8, 13, 21, 34, just 50 to 50 is very slow. I'll explain you in the next clip that why it's very slow here. And sorry, can you see? It's already overflow. Okay, guys, so I'll stop this and explain what happened in this scenario.